Okay, so this is the second model for solving differential equations. And we're just going to focus on part C. You can definitely do parts A and B. Those are review topics. But we're going to just focus on part C, which is the solving the differential equation part. So it says find the particular solution y equals f of x with the initial condition f of 1 equals 2. So there's our x, there's our y. So for part C, we really only need to look at the derivative, not the second derivative. So emphasizing what I mentioned in the first model is since our derivative is not solely in terms of x, we do need to do this separation of variables. So we're going to cross multiply. So we're going to get dy equals xy cubed dx. Very similar to the first one, we're going to divide out by y to the third. And I'm going to write it as a negative exponent. And then we could move to step 2, which is to integrate both sides. Okay, and so once again, just a couple of power rules. So we're going to add 1 to the exponent and make sure we also divide the original coefficient by that new exponent. On the other side, we're going to get 1/2 x squared, and then we're going to have just 1 plus c on the right-hand side. And now we're ready for step 3, which is to find the c value. Okay, and that's when we're going to use the initial condition given to us. So we have negative 1/2. Our y value is 2. And our x value is positive 1. Okay. This question was not calculator. So again, try not to use the calculator. 2 to the second power is 4, so 2 to the negative second power would be 1 over 4. And that would give us negative 1/8 on the left side, equals 1/2 plus c, minus the 1/2 over. So 1/2 is really 4/8, right, if I make that a common denominator. So my c value is negative 5/8. So now our job is to isolate y with the c value subbed in. So you want to take a look at your final outcome in step 2. And sub in the negative 5/8. And then start trying to isolate. So I'm thinking that I'm going to make the right side negative 1 over 2y squared equals 1/2 x squared minus 5/8. I'm going to probably just multiply everything by negative 1 right here. I'm going to have 1 over 2y squared equals, and I'm just going to rearrange it like I did in the last example, 5/8 minus 1/2 x squared. I'm going to multiply everything by 2 now. We didn't have this extra coefficient in Model 1, so we didn't have to do a step like this, but we do for this problem. So I'm going to have 1 over y squared. This is going to bring us to 10/8, which is 5/4. And then don't forget to multiply this term by the 2 as well, and that's just going to give us minus x squared. I really like the reciprocal technique. You can only do the reciprocal technique if both sides are expressed as one fraction, so we don't really have that on the right side. But we can easily make that happen if we multiply the x squared by 4 over 4. So that's going to give us 5 minus x squared, 5 minus 4x squared all over 4. Then we could do the reciprocal technique where we have y squared equals 4 over 5 minus 4x squared. And we do have this additional step in this one where we have to square root both sides. Now this is very important. This can definitely lead to wrong answers in the future. When you square root both sides, we have to remember that the solution could be positive or negative. I'm also going to simplify this up just a little bit. The square root of 4 is 2. And the square root will remain on the 5 minus 4x squared. Okay, now, we're not ready to circle this as our final answer because we do have to do step number 5, which is to check the initial condition. Now we have two equations that are possible answers, right? We have this one, or we have this one. Now our initial condition was f of 1 equals 2. So my prediction is this is going to be the keeper, but let's just verify. And I think it's definitely working out. 2 is equal to 2. This one is going to lead to a false answer. You're going to get 2 equals negative 2 over the square root of 1. And we know that 2 is not equal to 2. So this one would be rejected, and this one would be kept. So this is our final answer to model number 2.